So I woke up this morning and I was very excited. I can't say it any other way. I came up with another crazy idea. My idea this morning when I got up was these are NEMA 14 extruder motors. So they have a little gear pulley on. Normally, what we see very often, 8 gears, 10 gears. I'm not going to go into detail in the gear ratio, but I know since my own experience that if you take a conventional printer, any printer that you got or that you built originally with 24 volts, and you increase the XY motors from 24 to 48 volts, you get more speed. So more voltage, more speed. The amperage is responsible for the torque of the motor. Now, these little motors, we know that they have torque. I mean, they can pull easy 8 kilogram spool of filament. So they have the torque that we need with a gear ratio on them to pull our filament. But what I've noticed, as soon as I try and push the printer to print 800 millimeters a second, or even higher, 900 or 1,000 millimeters a second, and we're talking with a nozzle diameter of 0.4 millimeters, it's like I'm not getting, I don't know, people tell me always it's restriction on the nozzle, the back pressure on the nozzle. But what if we increase the power of this little motor, and maybe if it can spin faster, so actually rotate faster, like on the XY gantry, then, or the axis, not the gantry, but the axis, won't I be able to get more speed out of it? And I haven't found anything. I do know one or two members in the Discord that do run 48 volt on these little motors, but I've never tested it myself, and I didn't find any information about it. So that's my crazy idea. Let's put 48 volt onto a NEMA 14 motor. Now, that will come with some consequences. I mean, you can fry these motors. I do have a lot of them, so I'm not worried about testing it because I've got a lot spare. And let me do this test for us that not everybody starts frying the motors. But the idea is to put water cooling at the back of the motor. This is the version 1 Extruder. You can see that because it doesn't have that filament clip part at the top. And this guy is in my setup responsible for the heat break of the hot end to cool that down. So the heat break goes in there. And I would say this water cooling part does mainly the cooling for the Goliath short to cool the heat break. But the contact area of the motor, if we look over here, it's really minimum. There we have a little part that is touching the aluminium. At the bottom, we've got this little section here that is touching the aluminium. And at the bottom, it's actually not, there it's I would say 3 millimeter spacing. So the motor is not touching the aluminium plate. Therefore, I would say the water cooling of the Extruder is maybe helping 5 to 10% cooling the motor, but not more. And definitely running 48 volts on the motor will make it boil and make it very, very hot. Even that hot, so we will have probably more heat generated at the back, and this heat will transmit over into the aluminium part. I don't think this section down here, so downwards, will be a problem, but this upward section can become a potential problem with the heat. And the heat that we generate will, out of also own experience, if you have a lot of heat generating up here, you actually start warming up your filament, and your filament gets soft and expands, and it gets jammed in this top section over here through the heat that is generated. So the idea would be to keep the motor cool and so that it doesn't get that hot with 48 volt. So I had a look in my box, things that I collected over the years, and I don't have a water cooling block for the NEMA14 motor. I found one on AliExpress. I did order it, but it will only arrive in about 2 weeks' time, and I don't feel like waiting 2 weeks to test this. So I had a look at my collection box, and I found these copper blocks. I bought them originally to cool NEMA17 motors with. I have 2 of them, but I never used it. Somehow I didn't like just sticking it onto the NEMA17 and hoping that it will stay in contact with the motor. So the idea is good, but I never used it. But now, since I have them, I was thinking to take the NEMA14 and put this at the back of the NEMA14. So it would look like that. I can run the water cooling through here and it will cool my motor. But now looking at the extruder with a top plate on it, this is going to be a little bit big. Let's just call it big. So theoretically, it will look like that if I would just mount this now on here and run the water cooling through it. Yes, it will do the job that I'm looking for. But then I quickly open up CAD, and I created this this jig. So I already 3D printed it this morning. It was a quick print just to complete it. So this is just a negative space of this water cooling block. So this part would fit in here. So I can press fit it in there. The other part fits then at the bottom, like that. And there we can also see already the copper underneath it. And then I'm just going to take these sunk head screws, 10 millimeters long, and then I'm just going to place them everywhere in the hole so that I can actually sandwich these 2 parts together. And then I'm going to run it through the CNC machine to see if I can remove as much material as possible off this water block to, number one, make it lighter. That's the main idea, just to lighten it, and also make it smaller so you don't have this huge, I don't even want to know. This just looks ugly. I don't think I would mount it like this, but it will definitely do the job. I mean, if you don't mind this looking like that, just stick it on, put water through, there you go. But yeah, like I said, I'm going to mount it in here, run it through the CNC machine, and then we'll see if it came out usable or if I can just throw this away. I was also interested, I haven't checked the weight of it, but I think it will be a good before and after. So at the moment, we have 18.61 grams. This is the current weight of it. So this is adding, at the moment, if I would use this on the tool head, 18.61 grams to the tool head. And I would definitely like to make this, this water block smaller, less weight, so that it is more or less discreet at the back. So not everybody, you will notice the pipes, but not notice the water block. CNC wise, I want to CNC it in the shape of the NEMA14 motor. So with 2 holes that I can put little spaces in between and screw it onto the motor block itself, so I can really pull the water cooling block onto the motor. I think that's the only way to ensure, with the tool head moving and flying around sometimes, that it stays in position and it's there to do the job. I also planned in to cut a 10 millimeter hole in the middle to be actually, or to keep the bearing free. So this is an LDO motor on the printer. Currently I'm running a Moons motor, but just the Moons bearing is a little bit bigger. So just that if this is mounted, that the bearing is running free. I don't know yet if I'm going to use thermal paste. We'll see when I get there. Let's just CNC this. So that's the plan. I'm not going to demonstrate the print or the heat in this video. I will do that, excuse me, I will do that in a follow-up video where I will also show the secondary extruder, the M404, which I showed in a previous video. I will show in that video how this works. So the water cooling block on the toolet itself, in combination with the M404 secondary extruder, how the two of them work together. So just that you guys know. But what I'm definitely am going to show is how I set up the CNC machine to actually mill this. Maybe I'll do a fast forward process of the milling process, and then at the end I will show the results of the outcome, if it was usable or not. Lucky I have another spare that I found in another box this morning, so if this one should not turn out the way that I hope to, then I do have a second try at least. These files as well, I will put the link of this water block in the video description. Also, this file I will put on printables if somebody else would like to use it. Just a quick run through. So you're going to put 8 screws in total. So it's going to be 3 at the top, 3 at the bottom. Like I said, these are sunken screws, 10 millimeter, 1 on each side. That's the idea. Then you've got 3 round corners, and you've got the bottom corner. The bottom sharp corner is to orientate yourself. The DXF file I'll also put online. I always start seeing from the bottom left-hand side, so that's why this side has got a corner. And the CNC will move from this corner up to the material and start CNCing. So what I'm going to do in the first step is cut these 2 holes, or maybe even these 3 holes in the 3 millimeter. This middle one also has a hole on the other side, and I printed these with 2.9 millimeter hole. So I'm not going to put heated threads in them. We can just thread straight into the filament or the 3D printed part, because afterwards we're going to throw this part away in any case. It's not going to be reusable. So I'm going to CNC into these 3 holes, so that I can put even more screws in to keep the bottom part as secure as possible. And then I'm just gonna probably CNC through the 3D printed part all the way through into the through the copper. There's not aluminium but copper. So I just cut out the pockets that are designed. But all these files, so of this little jig that you can then mount on your CNC table, I'll put on printables in the link below. The DXF file I'll also be using. And I was looking for a bit, and I didn't find one in my normal box. So I still have the Milo that I need to complete. There's also a follow-up video coming from that later on in the year. But I found this in the kit, a little 3 millimeter upwards cut single flute end mill. I'm going to try and mill the copper with this. Maybe this is completely wrong. I'm not a metal expert, but I think for aluminium, this would definitely work on aluminium. So I'm hoping that the copper will do. Also, I'll do very small step overs, very small cut-off depth, because copper brittles. If you cut it, you get fine dust, and just that it doesn't start melting on the bit. So I'll take it really slow, and like I said, I'll put it in the video, but I'll fast forward it, because the experts would say, go faster, do it quicker. But I don't have a lot of these water blocks, so I'm rather going to be safe than sorry. So yeah, so next scene will be from the CNC table. And I'll guide you through what I'm doing there. I am down at the workshop at the CNC machine, and I did some prep work already. So I normally use, or I prefer to use painter's tape, the blue painter's tape. This is from Tesa painter's tape. It really holds very, very well. So I just on the back, so there we can see the copper underneath it. The corner, of course, will come on this side. I've added all my sunken head screws already in. So the sandwich is now complete. And if I shake it, nothing is shaking, so nothing should be shaking inside. Otherwise, the part will rattle around and we won't get a nice CNC cut. Painter's tape at the back. What I'm going to do now is I'm going to put painter's tape. I'll see where I'll put it so that it's nice on the video that we can see when I CNC it. Put some painter's tape down on the table. And then I'm just going to use a glue. I don't like using super glue. Super glue will do the job. I just don't. I moved on from super glue. What I do use is just a normal Uhu multi glue. This one is called Kraft, which means in German strong. So it's a strong bond. And I just glue it down and I leave it for about an hour, maybe 2 hours just to dry out. I like to put weight on it just to secure it down, and afterwards I CNC it. This is one option, and I've just gotten used to it when I CNC acrylic panels or polycarbonate panels. That's the way that I do it. Of course, with metal parts, I know already in the comments there will be clamp it down, you know, you have to clamp it down. But like I said, I'm not going to be aggressive on this, so I'm sure this method is going to be fine for what I want to do. I just surfaced the waste board, and I don't want holes in it now. But otherwise, I could have also used these 4 holes here and just screwed it down into the wood on the table. And that for sure would have also helped that it doesn't move around. But just something else. I mean, screwing it down is easy. Let's try something else. I think I'll put it over here so it's easy to see when the CNC is milling what the outcome is. The next preparation part I'll do off mic, and I'll probably fast forward it. So if you're not interested in this part, or if you know this part, just fast forward to the end when I'll be revealing the result after CNCing the parts. Just a very, very quick rundown what I did. I put down the blue masking tape. I use a little roller. I prefer this than just sticking it on because you really get the air bubbles out of the masking tape, and it really tacks better onto the wood where you want to CNC on. I used a little spacer, just a piece of wood. This is square to my gantry. So I've tried to align it as square as possible. This is not the best method, but definitely the fastest way just to get it mounted. I added some glue, more than what I would usually use. Normally I just add a little bit of glue. It's more than enough. And then for weight, I use diving weight. This is soft weight, so it's little lead balls, 2.5 kilograms, to really force the part down so that the glue can then bond to the masking tape. And like I said before, this takes about, the earliest I would say after 1 hour, best 1.5 to 2 hours waiting period before you really start milling. Otherwise, the chances are very big that as soon as you hit the metal part, that the whole unit will just start moving around or start flying as the mill starts milling into the metal. So I'll carry on filming and milling in about 2 hours time from now. Just a quick look after the CNC part, what the cooling block now looks on the extruder. So this is the extruder which I mentioned early on in the video. This is the one I'm currently running on my printer. Still have the nylon or the plastic gears. But then if we look at the back, that is the part that we now CNC'd. And it actually turned out pretty well. It's not the prettiest part, but also my CNC is not made to actually mill copper or aluminium. It's more for wood and plastics. So I'm very happy with the result, what it looks like. The hole is more or less in the center, so the bearing doesn't interfere, it doesn't rub against the cooling block, so exactly the way that I wanted it. I used some aluminium spacers. These are in total 14 millimeter. So there's about 0.4, 0.6 millimeter missing. So I could really bolt down the cooling block on it so that I have pull on it. I had to replace this screw at the bottom. This is a 35 millimeter screw with the spacers, and then just a lock nut at the back with a small little washer. And the one at the top is also an extended screw. I had to take the whole extruder apart to actually get the screw in, because this aluminium piece here is in the way, so you have to take it apart. But it's actually, you just have to loosen these two screws, so this one, to take the back plate off, and then the back plate comes off. You can insert the screw and just connect them back together again. So yeah, that's the end result. In the next video that I'm going to make, it's going to be then this combination with water cooling. So I'm going to finish up all the water pipes. I'm not going to do that in this video. And then also the M404 secondary extruder. I've had a lot of questions about that, how that works in combination with your main extruder. That video is coming. I will answer some questions in that video, but I still need to finish up a few things over here. So this is now going to be connected to the water. I have to see how I do these connections to secure it. And also connect all of the extruder motors now to 48 volt. I still need to test that. I haven't tested anything. Maybe this little motor goes up in smoke. I will see what the maximum amperage is going to be like that you can run on this motor, so that I can also share that experience. So if somebody is crazy like me and also wants to run the extruder at 48 volt, definitely you can use my experience and you don't have to fry your own motors. I hope you enjoy content like this. Please consider liking and subscribing to the channel, and I'll see you in the next video.